Can people hear now? Is this working? All right, we had the internet go out for like 5 minutes, so we're restarting now. I took out my video so that just to help on bandwidth stuff, I don't know what's going on. So I'm just gonna do sound and screen sharing. At what point did you guys lose me? Did you see any of the slides at all? Or should I just completely start over? All right, cool. Oh, I need to share a screen. All right, you should be able to see my screen now. So going back to the beginning, I'm just going to do like a quick run through of what is consensus, and then that way we can talk about how it relates to staking and validating. So in Polkadot and Substrate, consensus is pretty abstracted away from the rest of it. So like our consensus algorithms don't know anything about transactions or balances. Everything is just kind of data inside of a block. And so consensus is about how to produce those blocks and how to agree on what is the correct set of blocks. So we use hybrid consensus, Babe and Grandpa. Babe is responsible for producing blocks and Grandpa is responsible for finalizing them. So Grandpa provides deterministic safety, and it does so the only things Grandpa really cares about are that however you're building blocks, you respect the fork choice rule of Grandpa, which means that anything Grandpa marks as final, then you have to build blocks on top of. So you can't build blocks that conflict with the finalized chain. And then the other thing is that you have to be able to follow the chain with a light client, which means you have to be able to follow the block numbers with headers because we're voting on chains and not blocks. And then Babe is the algorithm that we use for block production, and it provides probabilistic safety. So one of the, I should check now, everybody hears me? Yeah, can somebody send a message in the chat that you can hear okay? Okay, awesome. So yeah, the cool thing about like separating the block production from the finality part is that it lets us remove like the ON squared limit on most PBFT. So most PBFT algorithms, you have ON squared in order to complete a round. And so Grandpa has this too. It's a ON squared complexity to complete a round. But the cool thing is that the block production part is not on the path of that round. So other PBFT algorithms in blockchain, you have to do this for every single round or for every single block. Whereas with Grandpa, you can produce a whole chain of blocks that you finalize at once. And so block production is only order n. So we're not really limited by ON squared in our block production, only in finalization. So Grandpa is another acronym, ghost-based recursive ancestor driving prefix agreement, and it's a two-phase round, or 2 phases per round, but you're voting on chains, not on blocks. So an example of this is that you have these 3 nodes. They're voting on these different chains, but they don't have to agree on specific like blocks one at a time. they can all see that they agree on blocks A, B, and C, and so that chain gets finalized. Even though none of them actually voted directly on block C, their votes all get applied transitively to the older blocks in this chain. And so how we actually produce those blocks is with Babe, which is blind assignment for blockchain extension, and it's based off of Ouroboros prowess. So there's some more pictures coming up here that will help, but basically, like, we break time up into slots, and each slot has a slot leader. So the primary is based on a VRF, so it's randomly chosen. So VRF is a verifiably random function, and we set some threshold before each block, or before each epoch, which I'll get into later. But we basically say you input your private key and slot number into this VRF that you run locally, and if your output of the VRF is below some threshold, then you're the primary leader for that slot. But since it's random, not every slot will have a leader, and also, like, a slot could have multiple leaders in it. So if there's no leader, then we choose a secondary slot leader based on round robin. So we just go around all of the validators, and we choose the leader just kind of going around. And that way, if there's no primary slot leader, then a secondary slot leader can submit a block for that slot. And that's how we get a pretty constant block time of around 6 seconds. So how these actually, like, choose how to build chains. So when you're working on Babe and you're going to extend the chain, you have to decide which chain you're going to finalize. So part of the rule of Grandpa is that you have to build on the longest chain. So looking at this picture here, you have these blocks here that have been finalized by Grandpa, and then so this chain here at the bottom is kind of automatically illegal. It can't be finalized without a big problem. And then Babe has probabilistic finality for the other ones, so it's just going to build on the chain with the most primaries. So you can see this chain in the middle has 3 primary blocks. This top one has 1. This top one has 2. And so even though this is the shortest chain in blocks, it has the most primaries in it. And so that's going to be like the leading chain. Okay, so this is a question that comes up all the time in our validator lounge. Epochs and sessions and what is what here. So conceptually, you have 2 groups and they're very similar. So Grandpa, you have eras and sessions. And so an era is about a day, and it gets broken up into 6 4-hour sessions. Babe has epochs and slots. So an epoch consists of a whole bunch of different slots. The slots are about, or no, the slots are not about, they're exactly 6 seconds long. And we try to get 1 block for every slot. So if you've been following Kusama, you'll know that there are like 2,400 slots in an epoch. And sometimes the sessions change a little bit, or like some sessions don't have that much. So that's because not all of the slots get full. So sometimes we end up with like 2,200 blocks in 1 epoch. That's because 200 slots would be empty in that case. So yeah, so conceptually, these are totally different epochs and sessions, but I just kind of mixed them up talking myself. That's because in the code, a session is actually defined to be 1 epoch. So yeah, you end up having time broken into eras, sessions, and then sessions and epochs are equal, and then epochs being broken into slots, but conceptually these are separate. So Babe only cares about epochs and slots, and Grandpa only cares about eras and sessions. So this gets to be important when we talk about like updating our validators or having a new validator election. That has nothing to do with slots or epochs. Slots are just about block production. So the main question is, when do you get paid if you're a validator based on these epochs and eras and stuff? So rewards are done at the end of each era, and that's also when the validator election takes place. So at the end of each era, there's an election based on all the nominators that have been applied, and then the nomination takes place in the set changes occurs one session later. So I don't know if you can see my mouse here, but you're actually, if you win the election at the beginning of era 1, you're going to be a validator from session 2 in era 1 through session 1 in era 2. And then the new validator set will take over at session 2. So yeah, like I mentioned earlier, in practice, one epoch equals one session, even though they're different conceptually. And then slots can be empty. So that's why some of the sessions have different numbers of blocks than others. Although, yeah, we're kind of going for like 2,400 blocks in a session. And right now on Kusama, we're actually only doing like one session per era. So there's a parameter in Substrate that we can change to force a new era at the end of a session. And that happens when people get slashed, but you can also just set it up as a parameter or as an option. And so we're doing that right now so that we're having a lot of validator set elections happening. And just to keep things moving, like if we want to issue an upgrade or something, that can only take place at the end of an era. But once we launch more into production and get rid of pseudo and everything, there will actually be 6 sessions per era. So yeah, how do these elections take place? So we have this nominated proof of stake. You can choose up to 16 validators to nominate, and the election gets done based on fragment. So it goes through 2 steps. So the first step is maximizing the amount at stake. So it's going to go through all the nominators and all the validators and see how much has been, how they can how it can allocate the stake to have the most at stake. So the validator set's going to be limited. Say you have 100 validators and you've nominated some people that will be in the validator set and some that will not. It's going to shift all of your nomination to the ones that will maximize the amount at stake in the validator set. And then once it's chosen who's going to be in the validator set, it optimizes the distribution, and it wants to have the most even distribution possible. I think like it's kind of tough to just explain fragment only with words. So I put this link down here for our Learn staking page on the wiki. And there are some like diagrams and examples that'll help you walk through that. And then during an era, validators accumulate points. And so points get awarded primarily for authoring new blocks and for sending commit messages to finalize chains. There's also some points that get awarded for producing uncled blocks. But yeah, the majority of points are for producing blocks that end up in the main chain and for finalizing chains. So you'll notice that it's not related to how much a validator has staked behind it, which is unlike most other delegated proof of stake networks. So the validators only get points for what they're doing. And so even if you have twice as much at stake as another validator, you'll get the same rewards. And the points are kind of meant to even out. There's not really a way for a validator to be in a position to get more points, especially since the block production is probabilistic and all the weights are set to 1. So you're just going to end up with like even points over time. The rewards to nominators are distributed based on how much you have at stake behind that particular validator. So yeah, if we get into slashing and like what's going to be slashed, there are 4 major things that go on here. So one is being offline. You're supposed to be online and producing blocks, and the way you prove that is the easy way is just produce blocks. So if you've produced a block in an era or in a session, then you're considered to be online. But since it's probabilistic, there is actually a chance that you could never be selected to produce a block during a session. So in that case, we have this I'm online session key, and you can send a message with this like a signed message called a heartbeat to tell everybody that you're online. Equivocation. So in Grandpa, equivocating is voting on 2 blocks that are in different chains. So that kind of obviously goes against the idea of finality here, that you should only be voting on one chain. Babe equivocation is where you win a slot, so you're the primary author for a slot, but you actually produce 2 blocks instead of 1. So you should only be producing 1 block. And then unjustified votes, that's where you vote for a block that conflicts with the chain that's already been finalized. And so the slashing in here, so the being offline, that's quite a small slash, and then equivocation is like a medium-sized slash, and the unjustified voting is a very large slash. So we have this idea of superlinear slashing, and if you kind of followed along that, it doesn't matter how much you have at stake when it comes to rewards. You've probably figured out that if you have a lot of stake behind you, then your incentive is to run multiple validators. And so the question is, well, how do we stop them from doing bad things in the network if somebody has multiple validators? So with superlinear slashing, we actually adjust the slash based on how many people are offline or how many people commit an offense. I shouldn't have written just offline. So if only 5 people do one of these things, then they'll get a much smaller slash than if 20 people had done one of these. And that way, the penalty is much more severe depending on how many people commit an offense. And nominators also get slashed too. So you have to kind of do your due diligence in selecting who you nominate. All right, so we also have these account abstractions that help with a lot of this. So we have a stash account, and this is meant to hold funds and set your other accounts. So you should really only be sending 1 or 2 transactions from the stash account. So there should be a cold wallet, hardware wallet, paper wallet, something that doesn't really go online ever. And you just bond your funds and you set your controller and your proxy. Once you've done that, your controller pretty much does all the work for you. So it can set your preferences, how much of a commission you want to take, your payment destination, so you can pay your rewards to either your stash account or your controller. You can choose to add those rewards to your amount at stake, or you can just kind of take them as freely spendable right away. You can set your session keys, change your session keys, start and stop validating, set your nominations, kind of all this stuff, and you have the funds of the stash behind you. So you can make all these changes without ever having to sign messages with your stash key, which puts your funds at risk. And then this isn't really related to validating, but in governance, we have a proxy account. So you can also delegate a proxy account to vote on behalf of the stash. And I mention this because some other proof of stake protocols, the validators that you nominate can actually vote for you. So we don't do that. If you nominate somebody, they have no voting power for you at all. That's still completely up to you. So you can set a proxy account, which kind of does a similar thing as the controller account, except it's for governance and not for validating. And then we have session keys. Very common confusion is that because in Alexander, you had to create a session account to use. These are strictly not accounts. That was just a very bad thing that taught people to do the wrong thing in Alexander. But your session keys should never control funds or be an account. And these are only related to validators. They're if you're a nominator, you really have nothing to worry about as far as session keys go. And these are used for signing consensus-related messages. So we have Babe, Grandpa, I'm online, and Parachain ID. So Grandpa is ED25519, and the other 3 are SR25519. Although Grandpa, we're looking to change to BLS. But Babe, we need the SR key for running the VRF. Grandpa you use to sign votes. I'm online, you use for the heartbeats, and Parachain ID we use for matching validators with parachains. And these keys live inside of a client's key store. So they're living like actually in the client, although it is on our roadmap to add remote signing so that they don't have to. But for now, you need to sign messages inside your client. And you can set them with this function called set key from the session module. And so kind of the way this works is this is kind of what ties your actual validator to the validator that you've said, like with your controller, when you say like, I want to be a validator. What this does is set key will send a message, it's a signed message of your public keys, of your session keys to the chain. And then it just tells you like, whoever is signing messages with these keys, that's my validator. And then when you run a validator with the -- validator flag, it's going to look on chain for the set of keys that are registered on chain. And then it's going to check, oh, do I have any of these keys? And if it does, then it's going to start signing messages with them on behalf of your validator. So I think David's going to talk a little bit about upgrading validators, but this is kind of how you can switch over validators. So if you want to run 2 validators, you can set up a second validator with different keys in it, and then set keys to those ones so that you can take your primary down. So when you use set key, the changes are going to take effect in the next session. And then, so nominator versus validator. So a nominator, you just have to set up your stash and controller, which actually gets done when you bond funds. So when you kind of in the UI or in the protocol, when you select the bond funds, it asks you to set up a controller right there. So those just get set together, the first two. And then you set your preferences, like do you want to get paid to your stash or your controller account? And then you just choose the validators that you want to nominate. And then there's not really anything more that you have to do at that point. You don't have to be online. You can just kind of like set it and forget it, as long as you're continuously happy with the validators that you've nominated. You can change your nominations, and you don't have to unbond or wait any kind of period. You can just change your nominations, and that will take effect in the next election. A validator has to do all that stuff, except choosing validators, of course, but it has to set a commission. So validators can take a commission that gets paid to them before it goes to any nominators. And then they have to actually run the infrastructure, which David will talk more about, set their session keys, manage their key store and database, and then find nominators. So we see a lot of people in our validator lounge like looking for nominations. So as a validator, you have a lot more responsibility about setting up good infrastructure and staying online and not equivocating, anything like that. So I think that's all for me. And now I'm going to let David take over.
Hi there. I'll just switch the video off in case we have issues again, and I'll share my screen. Just one moment. Okay. Okay, so I guess we can start with some of the basic infrastructure requirements itself. And I mean, I guess this would be initially say from the VM or the dedicated server side. I mean, we would normally recommend you at least using something like 2 to 4 cores on the system, just to make sure that I mean, there is enough CPU and memory available. I mean, often that wouldn't really be fully used, but again, I mean, better have a bit more than not enough. I mean, a decent amount of disk space again should be used, especially I mean, with your validators or your Sentry nodes. I mean, currently you should really have them the pruning set to archive. So I mean, you really are saving a whole bunch of the chain data. And obviously just be aware that you may need to upgrade these as well. So, I mean, especially in the cases of things like dedicated servers, where, it is a lot more difficult to get extra disks in, and be very aware of that before you start provisioning. I think obviously with cloud providers, it's really easy just to attach new disks. But yeah, with a dedicated server, it's a good idea to keep these things in mind. So, I mean, Joe was mentioning about the super linear slashing. And, if you do have a high amount of stake, the idea is to run, lots of validators instead of having one that you really, you're throwing a load of stake behind. I mean, also this kind of plays into the idea that if one validator is offline, I mean, there's pretty much no penalty, but if there's, if you have 10 of them offline, I mean, yeah, things are going to get slashed higher and higher. So the more distributed you are physically, but also over providers, if possible. I mean, all of this is good just for variety. So, any individual availability zone or any individual network provider's problem, you want it to impact your staking operations as little as possible. I mean, technically, people do run Substrate and Polkadot on Windows and Mac, but I mean, I guess on the server side, Linux is probably the best supported operating system, or what we really mean by that is most validators use Linux, so we're generally going to spot any issues there first. So, I mean, just kind of going over how we generally try and set things up. So this is in the event that, let's just say you have more than one validator and you want them split over a provider, preferably in again, multiple availability zones, and maybe even slightly different operating systems, or I mean, Linux distros or software configs. The idea is that we'll have Sentry nodes in front of the validators. So the validators won't be directly connected to the internet. So in this case, it's just basically a VPN mesh. And the validators will use the reserved only flag. So basically it will only connect to kind of libp2p multi addresses that it knows. So in this case, it would be an internal VPN IP, and then the nodes kind of libp2p key. And again, you can make this deterministic by using the flag node key, and then that will produce your public key for use on the network. And then the Sentry nodes that will be connected to the internet. I mean, obviously they should really be bare bones, hardened and stripped down operating systems with, a lot of logging. And, yeah, I mean, as much access control as possible. So for example, access to SSH should be restricted to, 1 or 2 known Bastion hosts. They shouldn't be, I mean, nothing except for the P2P port of Polkadot should be available from the internet. I mean, this as in, I mean, you should then rely on maybe the cloud provider's firewall, but also a local firewall. And if at all possible, I mean, also make sure that when there's breaches of this, I mean, for example, if your cloud provider does have a firewall and you have a local one, and you're starting to see you're blocking packets, then something is seriously wrong, and you should be alerting based on that. Also with the Sentry nodes and the connections to the validators, we don't actually necessarily want to rely on the provider's internal network and just assume that's secure. But also, I mean, we can also mesh these over multiple providers. You know, I mean, for example, within a provider, you may be able to peer between different regions or networks or projects. But then if you also want to connect some dedicated servers, some VMs, and maybe some transient systems, it's nice if you actually have a whole layer on top of this. So you're really not relying on any individual providers' features or peering or assuming their secure network. So in this case, we just create a mesh VPN between all of the hosts. And there's actually a really nice wiki page on this at the Web3 or at the Polkadot wiki on the secure validator page. So that's something really everyone should really take a look at if you're going to be running a validator. So beyond that, there's actually already some really cool deployment tooling available. So one of them, which is like extremely good, especially for testing, if you want to like scale up, scale down, and it has a whole bunch of built-in monitoring and metrics. So that's the Polkadot deployer, and that's in the Web3 Foundations page. So basically that will set up a Kubernetes cluster with a whole bunch of pods, like kind of, Polkadot pods, and they can all speak to each other with, say, like a custom chain specification, or it can connect to a public network, of course. But the really great thing about this is it also includes a whole bunch of auxiliary tooling and management tools. So things like Loki for log and graph aggregation. And it also has things like built-in plugins for things like matrix bots. So you can then report any issues or failures to the matrix bot or a matrix room. And of course, in the middle of all that, it uses things like Prometheus for scraping and things like Alert Manager for defining alerts. So again, I mean, you can have things like if, any nodes are, more than 10% behind the average of all the nodes finalized blocks, you can alert based on that. Or you can just do more simple metrics, like if a block hasn't been finalized within the last, 20 seconds, you can alert based on that. I mean, it's quite arbitrary, but it's a really, really nice tool. Especially for kind of experimentation and testing, but I mean also it is also like production ready. A second repo, which is again like I think super cool tool, is the Polkadot Secure Validator setup. So this is basically a kind of a Node.js wrapper on top of Terraform and Ansible. So you can also use like multiple providers with this. So I believe this supports currently AWS. It supports Google Cloud, Azure, and also Packet.com for actually provisioning dedicated servers. But again, if you wanted to add any other providers to this tool, once they already have a Terraform module available, it's really simple to integrate in this. And I mean, basically, most of the really good hosting providers do have Terraform modules. So it's really worthwhile looking into this. Now, in the event that maybe you have already deployed your VMs, or maybe your company for whatever reason, or you personally have your own method of deploying, you can also just use the Ansible part of the Polkadot Secure Validator, and that would take basically a bare Linux system and then also build it up into a really good state. Kind of like earlier where you have a bunch of Sentry nodes. So they'd be kind of just tagged as public in your inventory. And then you have your validator nodes and they'd be tagged as validator. And this will also do things like, add a whole bunch of extra firewalling. So, only the public nodes can really contact the validators. And of course, you can modify this in lots of different ways. But it's a really, really, really good tool. And I mean, it's worth just running it even on, I mean, even locally, you could run a few VMs or maybe even a few Docker containers if you were to open SSH and just play with the tool. It's really, yeah, it's well worth looking at. And then there's some other utilities. I mean, one of them, for example, is the dot exporter. And this would be a simple Prometheus exporter for a local Polkadot instance. So this would expose things like the current finalized block and yeah, the current block that's at the tip of the babe head. And then obviously, you know, I mean, you can also alert based on, you know, the differences between these or variations between hosts. And again, it's quite a simple tool, so it would be quite easy to extend if you wanted any other kind of custom metrics or statistics. And just one more thing based on that, there is actually a PR in to add some Prometheus metrics directly in Substrate, which would, you know, obviously then translate into also being available in Polkadot. And so, you know, there might be a lot more interesting, real internal things that can be exposed very soon. But yeah, I mean, I guess there'll be more on that once it's actually merged. So now, I mean, a typical question we got asked, and it was one of the questions already mentioned in the questions section, is how do I do an upgrade? So let's just say, I mean, you are already validating, you're creating blocks, but for some reason you want to move provider, move a host, maybe you want a bigger disk or, you know, whichever. I mean, generally the idea is you will run two validators or two hosts at once. So, okay, let's just say you have one host already running. So it's producing blocks and everything is fine. And, you know, the last thing you want is to get slashed in the in your upgrade process. So what you'd want to do is set up your second node and just have that sync the chain fully. Again, make sure it has the same options as the current one. I mean, most likely right now, you just want to make sure it has pruning equals archive. And make sure that this is up to the tip of the chain. At that point, you can start your new node with the minus validator flag. So this actually won't do any harm. I mean, it's not, you know, it doesn't have any permission to do anything anyway. But, you know, you can already set that. At that point, you want to run an RPC method on the new host, which is author underscore rotate keys. And this will give you a long kind of output of a public key that you can then use in the Polkadot JS UI. And then you submit an extrinsic called set key. And that will then update, you know, you need to submit this from your controller account. And then on the next session, your new host will take over. So at this point, you have to make sure that, you know, basically you have both of them running at the same time. And when the new session happens, you should see an I'm online key. And then you should also see it actually producing blocks. And at that point, when you see it, you know, producing blocks, that's when you can shut down the old system. There's also a wiki page on this on the Polkadot wiki. So that's it really from the DevOps point of view. So I'll leave it back over to Joe.
Yeah, thanks, Dave. There was one question in the question set that I think is for you, that should the validator or the specs you gave for the validator, should that also be for centuries?
Pretty much, yes. Because I mean, right now they're almost doing the same job. I mean, okay, obviously the validators are producing blocks, but I mean, it's not an incredibly intensive process. And I think right now, you know, I mean, with these, especially if you have any kind of decent amount of money at stake, I would always side on caution. I mean, you can always look at these systems and scale them down a little bit afterwards. But, you know, I mean, especially at the start, start a little bit larger and then scale as appropriate.
Cool. There's one other question here, or a couple other that I'm going to go through. So The first one is running a validator for a parachain. Does it use the same mechanisms that if you run a validator for mainnet? Can you also explain collator and what are the incentives of running a collator instead of a validator? Yeah, so this is a common confusion in Polkadot. So there is no such thing as running a validator on a parachain. Parachains have collators and the relay chain has validators. And it's like kind of that's that, like they're completely separate. So the incentives for running a collator instead of a validator are really parachain specific. So each parachain is going to have its own economic model. So if you're a proof of authority parachain, you don't even necessarily need to have a token or anything. You can just run collators because your collator set is chosen with proof of authority, and you just decide, yeah, these 10 people can be collators. Or you could have your own parachain token with inflation or transaction fees or however you want to do it, and set up your own incentives for running a collator. As far as Polkadot's concerned, like for the validators, we want to have about 10 validators per parachain, but you really only need one collator. Like only one collator needs to submit a block to the validators, and then there's going to be like 10 of them that are running it to verify it before it gets submitted into Polkadot for finalization. But really, it's up to the parachain to select collators and whatever incentive model they want for choosing them. So validators are strictly for the relay chain on Polkadot. Next question was regarding high availability. We would like to have a clear procedure to rotate keys and spin up a new validator in a safe manner. So I posted this link. I think it's probably easier to read through the steps than it is to explain it and not risk making a mistake. So we have this guide on the wiki about how to upgrade. This one, David answered. When Polkadot CC1 launch? I don't know. Around New Year, but like, yeah, we're pushing. We're pushing as fast as we can here, but can't really name a date. Okay, we're using substrate telemetry and telemetry exporter. I see you mentioned dot exporter. Does it replace the previous complex monitoring setup? Dave, can you answer that one?
Yeah, so basically they're actually, I mean, they're complementary, but a little bit different. So the dot exporter, for example, would be expected to run on all of the nodes, and then you check. You would, I mean, just like you run Prometheus, say on each of your VMs for gathering statistics, you'd run dot exporter on all your individual nodes, and then gather that data, and then basically, do whatever you want with it in Prometheus, and then maybe to Alert Manager. Whereas the telemetry exporter is a little bit different. It just runs in one place, which is the telemetry server, and then all of your machines are reporting to the central location. Although, I mean, you can also put the log level up a lot higher with telemetry and gather all sorts of things. So, for example, you can have things like your block propagation time. I mean, this isn't available through simple RPC, but if you use telemetry, it's available on the telemetry server, and then you export it from there, and then that goes into Prometheus. So they're actually quite complementary. But again, once the PR is in to add kind of a hyper endpoint for a substrate directly, maybe some of this stuff won't need to go to the telemetry exporter. But I mean, right now we personally run both. We see a value. I mean, we get different bits of information from both. And again, I mean, if you actually look on the private telemetry server and you set the log level to say 9, I mean, you can see things like all the alt finality gadget, the AFG votes and pre-votes, and that can be quite useful. And it's a lot, it's kind of it's kind of built in and already set to be able to send to telemetry, whereas through the simple local RPC interfaces, it's not currently possible. So, I mean, they're very they're complementary, but a little different. Hope that answers your question. Okay.
Cool. I'm going to take one more question here, and then I'll give it to Tim. So currently, how do the collator and validator share the reward distribution? Is there any governance involved on the decision-making process? So they don't share the rewards. So validators only know about Polkadot tokens and they get the dot tokens as their reward. Collators actually don't need to know anything at all about dots. So collators are presumably getting rewards from their parachain in the parachain's token, but they don't. Parachain collators don't even need to own dots or know that dots exist. So they're not getting any rewards from Polkadot. Being a parachain, it means you get to submit a block for execution every time that Polkadot has a block, so every 6 seconds. But you don't get the rewards from Polkadot. That's the collators and validators are completely separate in that regard. So with that, I'm going to get Tim here, and he's going to talk about staked.
I don't know, am I live? Did I just take the screen?
Yeah, I can hear you and see your screen.
I'm live. Awesome. Cool. So I'm Tim from Staked, and thought it might be useful to share how Staked thinks about the infrastructure we run and kind of provide some best practices on how we think about sort of making sure everything is safe and secure. So just quick who we are and what we do. Staked runs proof of stake infrastructure on 16 proof of stake chains right now. We work with about 30 of the bigger funds and institutions that invest in crypto, and then have about 2,000 or more delegators who work with us as what are principally individual investors. We basically have two sets of business. One is we run public pools, so we will run validator infrastructure on Polkadot, and we hope you will delegate or nominate to us. We also run validator pools and infrastructure on behalf of partners, and these are actually other staking companies, wallets or exchanges, people who don't necessarily want to do DevOps work on a day-to-day basis, but want to participate in the active participation that staking allows you to do. And so, I thought what we'd do today was just kind of run through how we set up our infrastructure. A lot of it's got some overlap with a bunch of the Polkadot best practices, but talk about some of those things. So as you think about your own setups or working with a partner, good questions to ask in terms of the things you should be doing. I think at the very high level, the way we think about our business and the technology infrastructure we set up is making sure you do not get slashed. I mean, it's great to get rewards, it's fun, but avoiding scenarios where you can get slashed is kind of job number one in the infrastructure. And so the things we think about, the big ways you can get slashed are, number one, some form of extended downtime. And that's got some kind of small penalty attached to it. But generally, you want to avoid it because it sets you back on the order of weeks in terms of rewards you can earn. And then number two is key security. So getting hacked is a big deal because that could mean someone else could set you up for an equivocation or some other bad event that leads to a large slashing event. And then the third is some variant on that, which is inadvertently double signing a block. And when we've seen this in other networks, it's almost always coming from some form of sloppy setup where there's a prioritization of either getting something up faster or just not kind of running through the real things you should to ensure that you're highly secure. So in terms of maintaining uptime, I think the core of this is data centers go down. So if you want to be up 100% of the time, you need to be redundant. Disks fail, so you've got to have the ability to have a hot backup that's ready to go, so that you're synced with the chain quickly, can switch disks and deal with it. And as a general rule, this never happens on like Monday at 10 a.m. It's always happening at 10 p.m. on a Saturday. So you need a combination of alerting and some ability to react to these issues 24/7. And so what do? We use Kubernetes to orchestrate a environment that deploys containers across multiple cloud providers. So we actually work with AWS, Google Cloud, DigitalOcean, and in some cases Azure and IBM Cloud, depending on specific hardware requirements we have. And so we monitor network conditions, data center conditions, and generally try to distribute infrastructure across these different cloud environments. And Kubernetes handles all of that, so that if all of AWS were to go down, you can be deployed in Google Cloud very quickly, and there's no downtime associated with that. And then behind the scenes, everything we do feeds into one pipeline. We use Sumo Logic for sort of taking all our logs, looking for anomalous things or errors, and feeding that into a monitoring and alerting system. Some of that triggers scripts that just either restart containers or set you up in a different environment. Others make sure that that a person gets immediate access and deals with the problem. In terms of how we architect, basically on every chain where we can, the bit on the left here is our kind of standard setup. We use the term listeners internally. Sentries is kind of a fine terminology as well, but every chain's got a little bit different. At the front of what we set up, we've got DDoS protection. We run multiple listeners. Some are kind of easy to find in our network environment. Some are hidden, so that we've always got a set of nodes that are syncing with the chain. And behind the scenes, the block producing nodes, any node that's going to sign a block, sits in a private network and only peers via a connection directly to those listener nodes. We use intrusion detection via Falco on all the containers. So if any human being, we generally, no human being gets onto a server. It's all done via programmatic interface. And if somebody gets onto the server, there's an immediate alert, and people you've either got to have a real good reason for it, or the container is immediately destroyed. We also use vulnerability scanning and image validation on the software, so that you're not getting some form of faulty software. That's a big risk in the hacking environment here, is that you manage to get tricked into putting a bad image out and start producing blocks that then you can potentially equivocate on. And where we can, we love to use remote signers, so that we use encrypted keys in general, but if we can use either a MPC or an HSM to sign in a remote signing environment, that's what we love to set up, because we think it's the most secure. And then I think the last bit I wanted to touch on was just some final thoughts around sloppy setups. And this is basically where we've seen other people get slashed in the past. The number one comment I would say is that there's a little bit of a wrong obsession in my mind with 100% uptime. I think it's better to take a little bit of downtime and ensure that you never double sign a block or equivocate, versus some kind of a vanity stat like 100% uptime and have some real risk of running two things side by side. So in one environment where we saw someone get slashed, they were running 2 hot signing nodes at the same time and didn't handle the switchover appropriately, and that was a big mistake. Number 2, if you're bringing up a backup that's going to sign with the same set of keys, make sure the other one is down. There was a slashing event on Cosmos where unfortunately someone thought their original node was down and they were bringing up a replacement. Turned out it wasn't, and immediately 5% of their stake vanished because of that kind of thing. And so I think in general, a great best practice is never run 2 live block signing nodes that have the same keys on them. I think it's that's a good general practice unless you're really advanced and you know what you're doing there. And then I think modifying the software and getting into the guts is how things go wrong here. So unless you are a very savvy Polkadot coder, I would really think twice about doing any modifications to the core code unless you've got a really clear reason as to what you're doing there. So that's us. You want to keep up with us, we are at staked.us. We've got a Twitter account, Medium, a newsletter, and happy to chat with people who want to talk about this. If you've got ideas on how we could do what we're doing better, would love to hear it.
All right, is that all you had for your presentation, Tim? All right, looks like Tim left as a presenter. I think we got all the questions answered. There was one open here, a new one about gossip issues, which I don't know off the top of my head. So if you have like a specific gossip issue, you should definitely open an issue in the Substrate or Polkadot repo, and we'll get it fixed. But yeah, we're going as fast as we can on Kusama and getting to Polkadot CC1. So I think with that, we will wrap it up. Thanks everyone for attending.